Hello, Algebra 1 Essential students. I hope you're having a great day. This video is going to be about getting ready for a quiz, so there will not be an assignment at the end, but this is just a review of the kinds of stuff that you're going to see on the quiz. So here are the topics that you're going to see on the quiz, and these topics are the topics that you can find in Google Classroom. So if you haven't done these yet, you probably should. And this video can actually help you do those things because it's going to touch on all of these topics. There's forms of equations, graphing equations in standard form, finding slopes from graphs, finding slopes from tables, the slope formula, identifying slopes and intercepts, and graphing equations in slope-intercept form. Each of these topics are on Google Classroom and come with a lesson video and a practice assignment. So if you haven't watched the videos, if you haven't done the assignments, you probably should, so you can get some practice and do well on the quiz. Before, yeah, that's what that says. So in this video, I'm going to do a problem from each topic. If you'd like to, you can start a new note page for these, or you can just add to the notes you already have. All right, let's go. So where we left off, well, where we started, I guess, after the last quiz, was with a topic called forms of equations. And what we learned was that linear equations come in many forms. And all of these forms of equations make a line, when you graph them, and each one is useful in its own way. And so there is the slope-intercept form that you see right here. And it looks like y equals mx plus b. And this tells us that m is the slope and b is the y-intercept. And if you've done the assignments about graphing in slope-intercept form, this is familiar to you now. And then there's a form called point-slope form. And it looks like this here, and it looks a little bit crazy, but it's actually my favorite. I don't think we're going to get to use it this year, but it's pretty cool. I like it. Again, m is the slope, and this x1, y1 is a point on the line. That's why it's called point-slope form, because it tells you those two things. And then we talk a little bit about standard form, and that looks like this here. Ax plus by equals c is what's called standard form. We didn't talk about intercept form at all. Even though it's pretty cool, we're not going to worry about it at the moment. Vertical form we talked about, and that's when you have an equation that looks like this: x equals a number, and then horizontal is when y equals some number. And we've talked about all five of those. So the kinds of questions that you'll see for this is, what form is this equation? And you're just going to kind of match it up. Well, notice you've got the y by itself, and then equals, and then some number x plus some number. That looks like slope-intercept, doesn't it? It doesn't look like any of the others, and so you'd write slope-intercept. And that's all there is to that. What form is this equation? Well, the y is not all by itself, so that one doesn't work. And there's no parentheses, so that doesn't work. And we weren't going to use this one at all. So it looks like standard form, doesn't it? Because it's a number x plus a number y equals a number. So this is standard form. All you do on these is name the form. All right, here's another one. What form is this equation? Well, it looks like it's just x equals some number, and the only one that looks like this is like that. So it's vertical. That is the vertical form. All right. So that's how you recognize forms of equations. And then we kind of started working with the standard form, and we noticed that we could be very clever to graph a line that was in standard form if we use what's called intercepts. And it was really just a matter of understanding that this line crosses the x-axis, and it also crosses the y-axis. So it has x and y intercepts. Most lines do. And so we can use that idea and that y equals 0 and solve for x. And then to find the y-intercept, let x equal 0 and solve for y. So let's find the x-intercept. So how you do this is you take this equation that you see, 3x plus 4y equals 12, and you let y equal 0. So you'll have 3x plus 4 times 0 equals 12. That means that this thing goes away, because 4 times 0 is 0. And so what you have is 3x equals 12. And then dividing both sides by 3 gives you x equals 4. And so you have a point. When x is 4, y is 0. And you can put that on the graph. The point 4, 1, 2, 3, 4 zeros right here. This is your x-intercept, where this line is going to cross the x-axis. And then the next thing to do is the y-intercept. Well, that is going to be where x equals 0. So we take our equation, 3x plus 4y equals 12. And this time we put a 0 in for x. And so we have 3 times 0 plus 4y equals 12. And then that goes away because 3 times 0 is 0. So we have 4y equals 12 left over. Dividing by 4 on both sides gives us that y equals 3. And so when x is 0, y is 3, and our point is at 0, 1, 2, 3 right there. And then all we have to do is connect those with a line. Done. That's how you use intercepts to graph an equation. You just work that equation with a 0 in for y, and then a 0 in for x, and figure out the point. From there, we decided that we could find slopes from graphs. And so this asked us to describe the slope of the line, and then find the slope of the line. Well, the key thing here is that the slope equals the rise over the run. That's where we started talking about that. And so we have to figure out how many places we're going up and down, and how many places we go left and right to get from one point to another on a line. But to describe the slope of the line, we have to just kind of take a look at the direction that this line is going. And that's a matter of looking how it's going from left to right. In this first part, I'll call this one number 1, the line is going down when you look from left to right. And so when we describe it, it's a negative slope. In number 2, the line is going up from left to right. So this is a positive slope. That is the description. And now we're actually going to find the slope of the line. And that's where this comes in. Slope equals rise over run. Because what we can do is we can connect the dots. We can figure out how far it takes, how far we have to go to get from negative 4, 3 in this first line over to 1, 1 on the line as well. So it's really just a matter of counting and noticing which direction you're going in. When I'm starting at negative 4, 3, and I want to count how many spaces this line goes down to that other point, I'm counting down 1, 2. And since I'm going down, I call it a negative 2. And then I have to go to the right, or the positive direction, 1, 2, 3, 4, 5 places. And so, because the slope is the rise over the run, I'm going to take this negative 2, because it's the one that goes up and down, and put it over the 5, because that's the one that goes left to right. And there's my slope, negative 2 fifths. The rise, this part, over the run, this part. All right, we can do this again for number 2. Oh, and notice that this slope, this 2 fifths, is negative, just like we thought it would be. Now let's take a look at this other one. We're just going to see how far we go left to right, and then up and down to get between our 2 points. So going from negative 3, negative 1, I'm going to the right, so that's in the positive direction, 1, 2, 3, 4, 5, 6 places. And then I have to go up 1, 2, 3, 4 places to get to that second point at 3, 3. So because I want the rise over the run, this is the rise. So I'm going to put the 4 over the run, which is 6. And for me, you can leave it like that, but you might have to reduce. 2 goes into 4 2 times, 2 goes into 6 3 times, and here's your slope. Done. And notice it's a positive number, like we expected it to be. So that's how you find slopes from graphs. Now, how do you find slopes from tables? Well, let's put the instructions there. First, you find the change in x, then you find the change in y, then you put the above values into rise over run, and then you simplify. That's all there is to it. So what do I mean by finding the change in x? Well, for example, how do you get from 4 to 7? Well, you think you have to add 3, right? 4 plus 3 is 7. Going from 7 to 10 is also plus 3. Going from 10 to 13 is also plus 3. So our change in x is 3. Now we'll look at our, so we took care of this part. Now we'll find the change in y. Well, to get from 20 to 14, I have to subtract 6. To get from 14 to 8, I also have to subtract 6. To get from 8 to 2, subtract 6. And so negative 6 is my change in y. So now I'm going to put the above values into rise over run. Well, rise over run is like the y values, because that's up and down, over the x values. And so what we're going to put is the y values on top, negative 6, over the run values, which is 3. And then we can simplify. Negative 6 divided by 3 is negative 2, and there's your slope. That's the slope of that line. Okay? Now let's do this for the second table. Find the change in x. Well, from 0 to 2 is adding 2. From 2 to 4 is adding 2. And this is consistent. We're going up by 2 every single time, and so our change in x is 2. Done. Now let's find the change in y. Let's see, we get from 3 to 11. 3, 4, 5, 6, 7, 8, 9, 10, 11. You have to add 8. Is that the same going from 11 to 19? Yeah, it is. You have to add 8. And from 19 to 27, you add 8. And from 27 to 35, you add 8. And so that's our change in y, 8. Now we're going to put that into rise over run. And remember, we want the y's on top and the x's on the bottom. So we have the 8 on the top and the x's on the bottom, which is 2. We'll do that. And then if we can, we're going to simplify. 8 divided by 2 is 4. And there is the slope of that line. So that's how you can tell a slope from the table. All right, and then we started talking about the slope formula, and it looks like this. M equals y2 minus y1 over x2 minus x1. And then you just take the values from the points, put them in the right spot, and calculate. Where do these x1s and y1s and x2s and y2s come from? From these points. Because here's an x value and here's a y value. Here's another x value, and here's another y value. The x's always come first, and then the y. And because the negative 2, 6 is just the first point in the sentence, I'm going to say that that's x1 and y1. And then 14, negative 5 is x2, y2. And now I'm going to replace the pieces of the formula with those numbers. Oops, I dropped my pen. So a slope is going to be y2, first of all. Well, that's negative 5. It's right there. Negative 5 minus y1, which is 6, over x2, which is 14, minus x1, which is negative 2. So minus negative 2. You've got to have all those minuses in there. And I wrap those up in parentheses just so I can remember that that's a negative there. And now it's just a matter of simplifying. Well, if I take negative 5 and I go more negative 6 places, negative 5 minus 6 is negative 11. And then negative 14 minus negative 2. When you minus a negative, it's almost like a plus. So 14 plus 2 is 16. And that is already reduced. And there's the slope of that line using the slope formula. You just label the point and drop the numbers in the right place and then simplify. And then after we talked about slope formula, we talked about being able to identify slopes and intercepts. And this is in particular in the slope-intercept form of a line. And the reason why the slope-intercept form of a line is so great is because you can just look at this equation and know what the slope of the line is and where it crosses the y-axis. For example, in part A, we know that the slope is 3 because it's right there in front of the x. The number that's in front of the x is going to be the slope. And then the y-intercept, or b, is the number that's in this spot. And you've got to include the negative if there is one. So there you go. That problem's done. The slope is 3, and the y-intercept is -4. In part B, the slope is 6.5. It's the number in front of x. And then intercept is 7. It's the number at the end. And then in part C, the slope is -5, and the y-intercept is 12. And that's how you identify slopes and intercepts. You just pull those numbers out of the slope-intercept form. And I think the last thing we did was learn how to graph an equation in slope-intercept form. And here are the 3 steps. You're going to identify the slope and the y-intercept, which is what we just did. We're going to plot the y-intercept as a point on our graph, and then we're going to use the slope to get more points. So for number 1, I'll do this one in red. The slope is 5/7, and the intercept is 2. Now we know, so we've identified the slope and the intercept. Now to plot the y-intercept, we know that the y-intercept is where the line crosses the y-axis. And so here's the x-axis, and here's the y-axis, and we know it crosses the y-axis at 2. So we're going to put a point at 2 on the y-axis. So we plotted the y-intercept. Now we're going to use the slope to get more points. Remember that your slope is a rise over a run. And so the rise is 5, so you're going to go up from the points that you have already and count 1, 2, 3, 4, 5. And then the run is 7. So it's positive, you're going to go to the right 7. 1, 2, 3, 4, 5, 6, 7. And there's another point on your line. And you could do that a bunch if you had room, but we don't. So we're just going to connect those 2 points. And that's what our line looks like. All right, let's do that again, this time on blue. First of all, oops, I forgot to this part. To get more points. We're done. All right, let's do the next one. So we're going to identify the slope and the y-intercept. Well, the slope in this equation is 3/4, and the y-intercept is 3. So we're done with that part. We're going to plot the y-intercept by putting a dot at where y equals 3, and that's right here. So we took care of that. And now we're going to use the slope to get more points, where our slope is our rise over run. So we're going to go up 3 and to the right 4 from our intercept. Up 3, 1, 2, 3, and to the right 4. 1, 2, 3, 4. We can do that again if we want. 1, 2, 3, 1, 2, 3, 4, and get another point. We can do that all day. We can get all the points on the line if we want to. And we'll just connect them. Done. That's how you graph an equation in slope-intercept form. You identify the slope of the y-intercept, you plot the y-intercept, and then you use the slope to get more points. That is it, you guys. That's all there is to this quiz. It will be dropped on the Google Classroom the day after this video drops in the Google Classroom. You can do this. I believe in you. Take care. Bye.